Hello, my name is Olmira and I'm a senior in high school. For my senior research project, I decided to look at what factors influence the persistence of non-men of color in STEM. And for my experiential project, I decided to build a telescope for under $50 that was self-standing, adjustable horizontally, has great magnification and clarity, and is also made out of accessible materials and tools. And so in this video, I will be showing you how I built that, and also we'll be sprinkling some interesting facts about some women in STEM that have influenced my persistence in STEM. So let's get into the process. For this project, you'll need hot glue or super glue, black paint, and it can be spray paint, scissors, any kind of sponge. I'm using a very sturdy sponge, some kind of small mirror. I'm using a compact mirror, but I actually had to cut it down so that it could fit in the pipe. And then if you build your own base, you will need a 13-inch wooden disc diameter and then some wooden planks. Additionally, you will need a PVC pipe. Mine is around a foot long, and I got it from Ace Hardware, as well as the T-valve that's 2 inches in diameter. So you'll also need lenses. So I ended up using 500 focal length concave and convex lenses, and I'm actually just showing you the difference between 300 convex lenses, which is this clip right here, and then 500 convex lens, which gives you a far more magnified image, and it's very crisp. I don't think the video of the iPhone actually does justice to the appearance of the lenses. The first thing you want to do once you've gotten your materials is get measurements of the length of your pipe and the inside diameter of it. So the inside diameter of my pipe was around 2 inches, and I realized that my lenses themselves were about a 1/4 inch smaller. So I had to make an adjustment in my cardboard by cutting out a circle inside of the disc of cardboard that was at a smaller diameter than the lens itself so that it could fit snugly inside of it. So then I went ahead and hot glued it together. The glue actually makes your seemingly flimsy piece of cardboard really stable, so I would actually not worry about if you think your cardboard might bend a little bit, because your glue will definitely keep it secured. Something really important that I want to note is that this project is very dependent on the types of lenses that you purchased. I will actually link the $15 lens set that I purchased from Amazon, because it has a diversity of convex and concave lenses, so you can actually get a variety of different appearances in your final image. So I went ahead and looked at convex and concave combinations of lenses. But if you use something like a magnifying glass, you will probably have to do a lot of work to find a complementary lens that gives you a really nice quality of image and really good magnification, since magnifying glasses just have a very differing focal length from the types of lenses that I used in this project. Moving on to what's happening with this T-valve, I actually found out that the inside diameter is quite a bit larger than my other PVC pipe, so I had to make the cardboard disc a lot thicker than I ideally would want to. You don't need to use a T-shaped pipe, but if you do, you won't need to use the mirror, and we'll just have an adjusted image. So now you can see I am painting the cardboard discs with black paint. This is a step that I would highly recommend, but is not entirely necessary, as blocking out the inside of the telescope itself will help with making sure that the light is focused onto the mirror that we will later be using, and so that the light doesn't scatter elsewhere. After I manually painted some parts, I went ahead and used spray paint to paint the main body and valve of the telescope, and I also went ahead and used nail clippers to cut some of the fray bits of cardboard off, as it was annoying me a little bit. I went ahead and started to transition into placing the lenses onto the telescope. So the first thing I did was figure out where I wanted them to sit, and then I placed a dab of hot glue to keep them very secured. I then went ahead and used the second piece of cardboard, which was the same size as the first, and placed it on top and secured it with hot glue again. I would also like to emphasize how important it is to keep your lenses and mirror clean at all times. So the lens that I'm placing on the outside here is the 500 focal length convex lens, which is also known as the objective lens, and it's the first one that light is focused through. So the next lens that we will be placing is actually the 500 focal length concave lens, which is the lens that light will be interacting with once it has hit the mirror that it will later come in contact with. This is also known as the eyepiece that we will be seeing from, and it's really important to make sure that it is straight and aligned so that the light doesn't pass through weirdly. I almost wish I used super glue or some kind of other really strong adhesive instead of hot glue, because it is so incredibly messy, and it kind of is why I'm a little bit displeased with the final result of the telescope, because it just looks a little bit too messy for my liking. We can see this when placing the sponge and mirror, which is in this next step. So I'm using an angled piece of sponge that I painted black, right behind the location of where the eyepiece is, and then I placed the mirror that I cut a little bit of so that it would fit. And this part was really annoying using hot glue with because it really just wanted to slip and slide, and you have to be extremely exact with the placement of your mirror because you have to line it up with the objective lens so that you can see it, but then also make sure it's visible through the eyepiece. So what I did to just cover this up, but also to make sure that light isn't escaping the back of the telescope, is just cut a piece of cardboard that is the same diameter as the outside of the pipe, and then just place that on the back. And so this step definitely made the telescope look a lot cleaner, but again, I was still a little bit upset with how the appearance of the hot glue was just kind of making the telescope seem a little bit less professional than I wanted it to, even though it was extremely sturdy. This signifies the end of building the actual telescope, and so for my senior project, instead of using some kind of pre-made base, I went ahead and built my own base. So I used 8-inch wooden planks to make the legs of the stool. I refer to it as a stool. And then I found out that the diameter of my wooden disc was around 13 inches, so I just approximated very roughly where each of the legs would be, so that when I went ahead to place them on with wood glue, which is something that I didn't include in the materials purposely because I don't actually recommend anyone build the base themselves. So you can see I'm using a saw and some sandpaper, some filing paper, so that the edges of the wood would be smooth to the touch. And then I just go ahead and place the legs approximately and keep them upright with some random materials I found around my garage, and then just use wood glue to place them down. As I have mentioned, I would really highly recommend that someone who's building this telescope doesn't go out of their way to also build this wooden base style. I definitely enjoyed and learned a lot about making a base out of wood. I've never built anything with wood before, but it was something that took me a really long time to perfect. I actually made a couple of mistakes with my wood, and some of it was cut a little bit less than it should have been, and there's also some splitting of wood because I also used an older plank that we had around my house. And so these kinds of annoyances are just not worth anyone's time who's just casually trying to build a telescope. That clip you just saw of that piece of wood falling off actually was really funny because it represented my mental state while building this base, because I was just having so many annoyances and the glue was just being a little bit finicky, and because I'd never done anything like this before, you can definitely tell in the final base of that little bit of unstableness, and there's a couple of physical discrepancies that I don't like. So this is actually an example of something that I would recommend someone using. This is just a random plant stand I found in our home. So there's lots of plant stands that you can find at like hardware stores. So now we're moving on to building the angle that the telescope itself rests on. So I wanted to initially use pieces of wood to build some kind of angle, but I just realized that was not very accessible. I was already frustrated enough while building the stool, so I actually went ahead and just used cardboard. So I measured out some pieces of cardboard with my telescope and then use the bottom length side to make a rectangular base. And then I actually had another extra piece of cardboard cut out that was in a similar triangle shape, so I stuck that in the middle, and that actually made that angle very architecturally sound and is the main way that the telescope rests on this angle. While I'm really glad that this cardboard technique worked out because it definitely keeps me under budget, it was something that I, again, was a little bit displeased by the appearance of because of my usage of hot glue. I really would recommend probably using a mix of hot glue and super glue because some mechanisms just benefit from the immediate structural support that hot glue provides, but super glue in certain instances like this is just something that I think provides a really cleaner appearance, and it's just a little bit easier to use because hot glue is just very finicky. I'd also like to clarify that the reason that we're using a mirror is that the concave and convex lenses on their own result in a 90 degrees counterclockwise rotated image, and the mirror alleviates this problem significantly. So after I built that angle, I went ahead and just painted it black, and this is pretty much what the telescope is going to end up looking like. So I went ahead and did the additional step of staining my stool because I just wasn't happy with the appearance of it, and I felt like it really helped the overall look. And then something I did to make the telescope more stable on the angle was place pieces of chopstick on the bottom and top portions of the angle, and then I also placed a black piece of sponge where the telescope will rest so that it doesn't rub against the wood. To decorate my project and give an ode to my research paper, I decided to paint flowers of important women in STEM from my life. The first type of flower that I painted on my telescope was the purple star flower in honor of my former physiology teacher, Mrs. Starr. She's a really important reason as to why I am majoring in biochemistry in college, and I also just loved her class in general. The next type of flower I painted was the sunflower, which is in honor of my mentor, Miss Carla Branch. These are her favorite flowers, and I really wanted to give an ode to her because her aid in this project was so significant, and I got so much insight working with her. The next flower I painted was the Virginia dogwood tree flower, which is a white color, in honor of Dorothy Vaughan, who is a brilliant mathematician and human supercomputer who worked at NASA and is known for overcoming major systemic barriers regarding segregation at NASA, and her story that was popularized through the movie Hidden Figures directly contributed to my interest in astronomical sciences. The Rosalind Elsie Franklin flower is a light pink hybrid flower that I painted in honor of Rosalind Franklin, a biochemist from Britain. Her major work finding the double helical structure of DNA was uncreditedly taken and published by her peers in STEM, and this has contributed to my interest in gender-based issues in the field. The most important woman that I have ever learned about in STEM and has directly contributed the most to my persistence in STEM is Henrietta Lacks. Born Loretta Pleasant, her cancerous cervical cells were taken without her consent and was developed into a cell line that has been used widely for biomedical research and has been important in the development of many vaccines. Since I read The Immortal Life of Henrietta Lacks my freshman year, I've been infuriated by the racial and gender-based injustice that she and her family have experienced as a result of her cells being stolen. I hope that if I ever come across her cell line in my research long term, that I will be able to have conversations about injustice, inequity, and a number of issues that BioWalk face in STEM. Additionally, I painted my favorite flowers, which are hydrangeas. So in these next two clips, you'll be able to see how this telescope performs in both light and dark conditions. My phone doesn't do a very good job of showing how well the telescope performs clarity-wise, since it looks quite blurry, but it's honestly quite crisp in person. I hope everyone who is interested in learning how to build a telescope was able to get something from that video, and I hope you also learned something new along the way. Thanks for watching!